So good afternoon, everyone. My name is Vignesh, and today I'll be talking about Docker, which isn't just another buzzword. It's actually something which has really disrupted the market in the last 10 years or so. So I haven't really worked with Docker in any enterprise scale project, so I thought I'd do some research, work with it, and I'm hoping to give you a little bit of an overview today. So before we actually dive into what Docker is itself, I think it's worthwhile to discuss the broader topics like virtualization, containerization. This will give you like an idea of the ecosystem and then the factors that support using of Docker and other containerization technologies. Why would you want to integrate Docker into your existing workflow? And the internals of Docker, which actually enable Docker to serve its goals, like the client-server interaction, the images, the containers, how all of them actually come together. And then I'll just give you a little bit of a short demo on some of these concepts. So I'm going to start with a very simple analogy, which is often used when comparing containerization and virtualization. And this is when we compare this to a physical office space. So in the past, if you were to search for an office space, if you're a small startup, you'd have to buy the whole office and often make a large upfront payment. And this is similar to deploying software, which could be really difficult. If you were to buy the whole server, you had to store the server somewhere and actually make sure that the server is operating online 24/7, and you would be responsible for all of this. Your second option could be you could buy the office on rent, just a portion of the office. Or what's becoming popular these days is co-working spaces where you just rent like a desk or a room, and it's shared by many companies in the same office space. You'd also need to manage all the services in your office, like your cleaning, your vending machines, and your different things. And this is similar to the physical space being your hardware, and the office services are actually like your software. And the office manager, the person who's responsible for making sure that all these services actually happen properly, would be your operating system. So in terms of virtual machines, you'd have a general office coordinator who would manage each of the floors. And you must also then have an own office coordinator to manage the services of your floor, who's more specific. But each of those office managers would have to figure out how the services are going to be done in terms of like how the vending machine would get work, how their particular floor would get cleaned, etc. While containers actually work like co-working spaces, where your property manager who owns the entire property takes care of those other services like your cleaning, etc. And you just have to benefit from the existing owner's operating system, as you say. So coming back to the actual tech part of it. So containers are actually compared to virtual machines because both the technologies enables you to run multiple types of software in a single environment in a different way. So when we come to virtualization, that will allow you to run many operating systems and software applications. All can run simultaneously, sharing a single physical machine. So for instance, you could have a Windows, a Linux, or different versions of maybe Windows or Linux, all running on the same physical machine, but as different virtual machines. And what would happen there is you would basically package your application code, your config files, your libraries, dependencies, and the OS all as one virtual machine. And your hypervisor will act as what is responsible for actually abstracting the physical machine from the VMs. While in terms of containerization, you still have a single executable package of software, but this time you will not package your operating system together with your application code and dependencies. The container runtime engine, instead of the hypervisor, would then be responsible for actually abstracting the OS from the different containers, and you wouldn't need a separate OS for each application. So in this slide, that's basically depicting all I've just said. You can see how bulky the operating systems are for each of our different apps that we're deploying into the server, while in terms of container engine, we literally eliminating that whole layer, and the operating system is just one. So there are a bunch of factors that you would actually want to compare when deciding why actually Docker or other containerization technologies are better. And we'll start with the memory usage, which is quite important. Containers are actually just the user space of your operating system. Basically, it's just a set of processes which are going to be isolated from the rest of the system, and they would all be running from the same image. And that image is what's going to be providing the files for that specific application. But virtualization, the hypervisor could actually make use of a little bit of your kernel space together with your user space. And one of the challenges here as well is when setting up a virtual environment, you often need to set up the amount of memory that you would like to use upfront. For instance, you might say 9 gigs of memory for a specific virtual machine on a server. But then when you're actually running the virtual machine, you find out that you're only using about 6 gigs. The other 3 gigs are not used, but you can't do anything with the memory. You can't reuse it. It's been allocated. While in terms of Docker, if there is any free memory, you can add more containers, and the containers can use the memory, or the rest of the system can continue using the memory, and that isn't disturbed. When we look at performance, a virtual machine actually since it has a full operating system, the hypervisor actually needs to translate all the operations that the operating system has from the guest virtual machine to the host server. And this actually uses a lot of CPU cycles. And the translation process is consuming so many resources that it's not really beneficial. And another issue with regard to performance is direct hardware access. So applications that run in a virtual machine often can't access the hardware directly, like your graphics card, for instance, while your containerized applications actually can do that. And this is a problem for a few application domains, I would say, something like machine learning. In machine learning, you've got some libraries, for instance, like TensorFlow, which often operate much better when working on a GPU, where you could train your neural networks, which are built in such a way that you could specify them as matrices, and the GPU runs a lot better with that. So containerization would definitely be better there. With regard to portability, if you're looking at relocating your app, you actually have to relocate the app and the operating system in terms of a virtual machine. While this also would mean the boot up times are a lot longer for your virtual machines, because the OS itself has to boot each time the virtual machine is started. So next, I would like to talk about some of the use cases as to why you even want to have Docker into your workflow. So basically, consistent and reproducible environments. Since your Docker has all its instructions in what you call a Docker file, and you deploy this Docker file with your code, the inconsistency between different environments is eliminated. Your development environments are repeatable, and every single team member in your team can basically use the same source files with Git, but also pull the same Docker images as others and work on the same environment to minimize this inconsistency. Then with regard to faster and consistent configurations, this is really good for new devs. If you've got a new dev in your team, and he wouldn't have to spend all the time setting up, and you wouldn't need to have a lot of documentation to actually allow him to learn how to get into this environment. And he can just use the Docker container, deploy, and get started with the actual work. When we look at your fault tolerance, if a disaster actually takes place, there's something wrong, you may actually back up your Docker images with what is called a snapshot. So running images can actually be committed and backed up. So if there's anything which causes a disaster, then you could actually use the same snapshot and revert back to the same stage and continue in the same environment. And finally, a very good use case is with DevOps. DevOps is really becoming popular these days, and so is the continuous integration and continuous development as part of your workflow. So you can ensure that how you are in your dev environments is how you'd move into QA, into pre-production, into production. So the move is a lot smoother, and your devs, your testers, and your system administrators, they all, whenever they want to do their part, there isn't anything new which needs to be done to set them up. They all work off the same Docker environment. So this actually now leads us to try and understand what our Docker environment is, what's in our Docker environment, what components actually form part of it. And as you can see, we've got a Docker client which will actually, you could interact with the client with your command line or your GUI, which if you're doing it through the cloud, your cloud service providers will give you a management tool that you can use, or you could use an SDK where you could program to actually talk with the Docker server from a specific programming language, if your use case demands that. Though the command line is the most common, and it would interact with the Docker host actually with a REST API, sending out REST API commands. Okay. So next, I'd like to talk about the main aspect in Docker, which is your Docker images and your Docker containers. So in terms of images, they are just a read-only files, which actually have the instructions for creating your container, for actually starting up a container on this Docker platform. So these images could be images that you're using just in your organization, or there might be a lot of images that you could actually get that are publicly available on Docker, which you could share with others as well. So your Docker image basically has your code, your config, your library and dependency files. They're all put together. All the files required to actually start up the container are all put into the image file so that you can have a fully operational environment. So the way you actually build an image, there are two ways you could actually build an image. You could build it interactively, or you could build it with a Docker file. So if you were to do it interactively, you would start by running your container. You'd run your container, and then you'd manually make the changes in the container. And then after making the changes, when you're happy with the environment, you would commit or save the state of that image, which would create a snapshot. And then you can go and share those images with others as your new environment. Another way you could use is actually use a Docker file, which is just a text file where you'd provide all the instructions for creating the image or the layers of the image, which brings me to my next point, as in this diagram. So each layer of a Docker image is built on top of other layers, and each layer is dependent on the layer which is below the layer. So if you change a layer right at the top of the stack, you wouldn't have to build all the layers below the stack. So the base layers would not have to be built. You just have to build the top layer. And when Docker actually launches the container from the image, it would add another thin layer right at the top of the stack called the container layer. And this is actually the layer which stores all the changes while you're actually running the container and you're interacting with the container, which allows you to actually take snapshots of the container. So this obviously means that you can have a lot of such container layers, which all share a Docker image, which actually is built up of many other layers or many other images. And all of these could run at the same time. Your first layer would be known as your parent layer, which is usually something like your Unix machine or something on top of which you could have a layer for your servers and things like that. And finally, as I said earlier, you could push your images to a local, you could push your images to a local repository, or you could have them in the Docker Hub where others can also share it. So you have push and pull commands to actually do this. Okay, so I thought I would just give a quick live demo of some of these aspects so that you could understand how easy it is to deploy a Docker application. So you first have to install Docker onto your machine. And once Docker is installed and running onto your machine, you could check firstly which images are present in your system with Docker images. Here, you can actually see the name of the repositories and the tags. So what this actually means is a particular image can have more than one tag, the latest tag being the newest of that image, while you could name an image with other tags to differentiate different versions or snapshots of the image. And you could view the images that are actually running currently on your system right now by going Docker PS. And the commands are mostly similar to your normal Unix commands, so it should be easier to understand. We can see that there's one image that's actually running now, and that's the testing image. So we're going to go ahead and actually stop this container, which is running off the modified image name. The name of the container is called testing. So we have stopped it. And now if we go and check which Docker containers are actually available right now, you see there's no more Docker containers if we stopped the active Docker container. Now, if we go ahead and want to run a Docker container, we would use the Docker run command. So here we're first we're showing what your ports are going to map to. So port 8080 on our local machine would map to port 80 on your container, and you could give it a name, and the name could be something like takeaway, and you specify out of what image this needs to run. So we're using an Nginx image. Okay, so basically, what I was going to say out of this demo is it's quite easy to actually get your Docker containers started. And the commands are mostly like your Unix commands. You could run your containers. You could actually build new containers out of your others with your Docker files. And the process is very simple. And even when doing it on the cloud, it would be even simpler using your cloud management systems. And I think that's all from my side in terms of a basic introduction to Docker. I'd advise people to also look into things like Kubernetes, Docker Swarm. These are other technologies that work together with Docker, where you could actually have many containers running at the same time, and you could operate them all at once. Thank you.